This is probably one of the coolest modules that we have. It's the dashboarding module, and it really proves out why Industry 4.0 can be useful by making use of mass amounts of data collection. You might have someone that just sits there and watches a machine, but I can guarantee you they weren't writing down every single time a case was picked or every single time a case was placed, when an e-stop was pressed, when the e-stop was reset, when a robot cell was entered, the list could go on and on. By using software, we're able to collect hundreds of thousands of data points, aggregate them, and put them into an easy to read dashboard. To calculate overall equipment effectiveness, induction rates, we can show downtime over the day, and all in an easy to understand graph. To whereas before, without all this data collection and data aggregation and analysis, it took either a process engineer or a data scientist to really understand what was going on with the system without the use of a dashboard. So with the use of a dashboard and the use of charts, basically anyone can look at this and say, okay, my machine ran really well today, or it didn't. It ran really poorly, strictly by looking at, how well your machine performed based on overall equipment effectiveness or induct counts, or looking at your aggregate of alarms over the day, or how much downtime you had. This is all capable through our dashboarding module. So with this, we can go into a demo on our software actually running. In this example here, what we have is an internal runoff at motion controls on one of our systems that we were testing. It's a simple single palletizer robot cell. And as you can see, right away, there's an active alarm showing that the robot is starved. This is a pretty common fault that we'll have in the robotics industry, to where it's not really, it's not a bad fault. It's just saying, hey, the robot's sitting there waiting for product, doing nothing, and it's being not utilized. So as we start picking and placing, what you'll see is the live data start coming in, and this is done through data collection through a set of sensors on the robot and on the conveyor. And through this, what we're able to see, data coming in, we're able to see the pick and place counts, what time the pick and place occurred, just very easily see how well the system is performing. So you'll see that the gate was opened. The operator had to go in and fix an error. So the machine was stopped in order to be in a safe state. And you can see how long that gate was open for. Now, right off the bat, since that gate was open, the availability on our overall equipment effectiveness module, it went way down just because we were opening that gate for a short amount of runtime. Now, as the system progresses and as the layers progress, you'll see that the system starts running a lot better, and our OEE goes way up. So our availability is going up, our performance is going way up, which is a calculation of your ideal cycle time times the total pieces that you ran divided by your operating time. So it's looking like right now we're at about 80% effectiveness. Now I think this machine didn't run at rate, so I don't think we'll ever get to 100%, but with this OEE module, you're able to easily see how well your machine's running just by a quick glance. To as before, you might be getting products out of your cell all day and not realize that you were only ever running at 80%. It's a really cool tool to be able to use and to have.
Yeah, again, Cam, I love the fact that we've aggregated, how many times the robot was starved for a total duration, how often the gate was opened, and that can answer a lot of questions for a customer when they're trying to diagnose what's going on with the cell and maybe why they're not getting quite the amount of production out the door they'd like.
Right. And with this tracking as well, what we're able to do is we're able to send out alerts based on how long the cell was starved. You can set up alerts to say, hey, the cell was starved for 5 minutes. I need to send out a text. I need to send out an email to let someone know. Because while we have this software running on our cell, a lot of times with big integrations or large production facilities, we might have other integrators' equipment feeding our equipment, and we might not know that the line's down or why the line's down. So by sending out these alerts, it'll alert an operator or maintenance personnel to go look at the system and they might find out, hey, the machine that's feeding the cell is actually causing the problem. It's not actually this cell itself. So one thing you'll notice is for this demo, the quality was at 100%. And that's because for this project, we didn't have rejects because we were expected good product. But to track quality, it's simply the percentage of good, or the good count over the total count of your items in the system.
One of the things I'm most excited about is the opportunity we're able to change the date and times of the dashboards to bring in more data or less data. So the opportunity to take all the alarms, currently you kind of look at what was the last alarm that we dealt with, you fix it and you move on. But if you can look at it over a week or a month or a year, and all of a sudden you pull in all that data and find out that there is a nuisance alarm that keeps occurring, and no one really thought about it. It happens once a week, but it's causing a lot of downtime. Now you can address something on a larger scale. So I think this is going to be super valuable in that area. You can also do this with the dashboarding to show events such as starvation or bottlenecks that you weren't aware of because they're so small. But when you look at a large amount of data over a long period of time, all of a sudden those issues percolate to the top. So this is a product that I'm very excited about, and it's definitely got that cool factor too, like Cam mentioned.